Hey everyone, this is Ira with the library's Makerspace. Today we're going to be going over our 3D printers and how those work. So I'm going to be going over a handful of things such as the components on a 3D printer, what they do, some of those things, where you can find 3D models online to print out, as well as how the software called the 3D slicing software is used in order to set up your print and communicate with the 3D printer itself in order to then create your model and have it printed out. So stay tuned and hope you enjoy this video. All right, so for today we're going to be exploring our Monoprice Maker Select V2, which was nice enough to be donated to us a couple years ago from some patrons here in Missoula. But this is what it looks like. And yeah, I will just slightly adjust this. So that's the spool at the top. That's the plastic that's going to get brought down into this mechanism, get heated up, and then adjust my camera real quick. This is the build plate area. This is where the model itself is built layer by layer. And as you can see, I've used some glue on there, just some regular stick glue on there just to basically help prints adhere nice and flat to the surface. And then moving on, this thing right here, this is called the control box. This has an LCD screen. This is where you set up essentially when you want to heat up the extruder mechanism itself over here in order to insert filament into the printer head. You're going to use this control box for all of that. And this contains things like its control board, so all of the electronics for the printer itself. It's also got all the mechanisms that help it heat up, and basically every electrical control is held in here. So this is kind of the overview of what it looks like all together. So yeah, we'll move on to the specifics now of the 3D printer head nozzle, and I'll talk a little bit more about all of those things. Okay, so this all definitely looks like a mess of wires, but they all have particular functions. And I thought that using the Monoprice would actually help pretty well because it's relatively exposed in terms of all of its components. So essentially right here, this is where the filament, the plastic filament, comes down, and right up here, there is a little spring. You can kind of see me doing that little spring tensioner, and inside that are some gears that basically grip onto the filament and then pull it straight down through here there's a thing called a heat sink, which essentially makes it so this area right here does not get heated up super hot, and this active cooling fan as well makes sure that this area right here is not super hot, so the filament can still flow through here and not get stuck or clogged up in this area right here. Up here in the front, this is an active cooling fan for when whatever item you're printing gets printed. It actively cools it, pushing air through there. Right now we're even more up close to the extruder mechanism. You could call all of this basically the extruder mechanism for the printer itself. One thing I forgot to mention too is back here, up here, it's what's called a stepper motor. That's basically driving the little gears connected to this little gear guy right there. The little hobbed gears inside of there is what's gripping onto the filament to push it down through out to the nozzle, and the stepper motor is helping with that. And then moving along, you can see, so this group of wires right here gets connected to this part right there, and these are called the heating cartridge wires. This is what's actually the component that's heating up the nozzle, and they call this area the hot end of the extruder. This is essentially where the plastic is getting pushed through and then heating up and then coming out through the nozzle, which I will show you a better shot of the nozzle in just a second here. But essentially these two wires are the thing that heats up this hot end right here. And basically with the type of plastic we mostly use, it's called PLA plastic, it's getting heated up to about 215 degrees Celsius, so it gets really, really hot. This set of wires right here that are connected inside the hot end. That is called a thermistor. That essentially is a temperature sensor that's giving automatic feedback via the LCD screen on the main board, control board. That's giving updated feedback of what the temperature values are for the hot end, as well as the this build plate as well. All right, so now we're even more up close, and you can actually see the nozzle itself. It is this part right here. Right there, that is where the plastic is being extruded out, and then it's going to build the whatever model that you're printing layer by layer on this build plate right here. So that's an up close look at this. Whenever a 3D printer is on, you do not ever want to touch that. This printer is off and it hasn't been on for a couple days, so it's totally fine. But anytime a 3D printer is on and it's heating up, you never want to touch this area because it gets super hot and you'll just end up burning yourself. But this just gives you an idea of what it actually looks like up close. You can see right here, that's the heating cartridge wires, that's the thermistor, and so the heating cartridge wires, once you turn on the machine and tell it to either print or heat up to a certain temperature, this area, this is actually this cartridge is what's doing all of the work and communicating with the main motherboard located in the control board area. So essentially, with all of these things together, it's once you set up a 3D print, the machine turns in the model into what's called G code, which is the X, Y, Z parameters that the printer is going to take in order to build the model from the ground up. G code also includes things like turning on fans, these fans at certain layer heights, etc. So it's just kind of depending on the print parameter settings that you set up in the slicer software, which we'll take a look at here in a minute. But altogether, essentially what happens is that this bed is going to be going back and forth, and then this is going to be sliding back and forth like this, and then it will create your model going from the bed all the way up until you have your completed model. And then all you need to do once your item's printed is we use one of these little guys to just basically pop it off the build plate. So it's a lot of kind of complex components, but all together, like, the idea of it is relatively simple. All of the electronics themselves are essentially either just heating up elements or turning on fans or controlling things like the motors for this or the motors back and forth for this. So, and all of those commands are done in this control box right here, which includes basically, you call it the control board or the motherboard, and you can turn it on and it actually will show you. That's the firmware that I've installed on that, and that kind of gives you an idea right now of, it's a little shiny, sorry about that, of the temperature values right now. So, and that will change once we start a 3D print. All right, so now that you've seen basically what the outside of the extruder mechanism does, and kind of you have hopefully a better idea of how that all works together, we're now going to jump into some websites that I use to look for 3D models. And then in the next portion of this, we're going to set up the print in what's called Cura. It's a program that's called a 3D slicing program. That's essentially where you import your 3D models in to get printed, and that's where you set up parameters like what size you want the thing printed at, if you need multiples of that print, etc. So stay tuned, and then after that I'll do a time lapse of the print, and then I'll show you how the print worked. All right, so in terms of actually looking for 3D models to print, two sites I really like include this one, Thingiverse.com, and the other one is called Yegi.com. Thingiverse.com, it's made by the company MakerBot. They make 3D printers. We have one of their older 3D printers here in the space, but I really like this website because there's just a large array of things to go through and look at in terms of models that people have made. And what's cool about these models is, say, if we wanted to print this baby Yoda, I'll click on that, and it's going to give us some more information about the model, a little bit of a summary, print settings, etc. But what's cool is what you can do is click download all files, and what you can do is actually print these out under a Creative Commons license, which just means that you're able to actually print these out without having to pay the person that created it. So if you have a 3D printer at home, or you would like to have us 3D print your this model or whatever model you find, we should be able to do that for you, and all we charge is the cost of materials, and right now it's 5 cents per gram of plastic. But essentially, it's free to download these files and print them out for your own personal use. If you wanted to actually try to sell these models, say at a market or online or something, you would actually have to contact the person that created it to get their permission and likely pay a fee. But in terms of personal use for these, you are free to download and print out models from Thingiverse. All right, so now we're back on the main Thingiverse page, and we're just going to explore a little bit more like what you can do on this website. So if you click on Explore and you click on Things, this will show you all of the 3D models that have been super popular in terms of downloads and people liking the models just this year. But what's cool is you can click on this thing and it'll give you the option to see what's the most made thing, what's the newest made thing, what's been popular within the last month or the last week. I'm going to click on Newest and we'll see what pops up. So these are actually all models that have been uploaded probably likely today. Like we can click on this paintbrush and storage model, and it looks like this is uploaded, today, June 23rd. So, and we can see this is actually an example of the printed model itself. We can click through the pictures and just see what it actually looks like in real life. And then when you click on this, when you get this, basically the models look blue. It's called the thing view, and that's basically just like the view of the model itself, kind of drifting in space. It's not an actual example of what the model is going to look like printed, but what's really handy is a lot of people that upload their models on this website have actually created 3D printed examples and then posted pictures, which is really nice. So say if I wanted to use this paintbrush and storage, want to download it and 3D print it, I would just click on download all files right there. Come up with this license, download files in 3, 2, 1, and then you'll get the zip file that you just click on OK and that will download for you. So I would just note that once you see, basically for any uploaded models, the ones in blue right here, it's always kind of a toss-up to know if they're going to be printing properly. What helps though is that we have a program and you can actually download it yourself at home. It is called NetFab. And there's a free trial that you can use. And what's nice about NetFab is that you can actually use it, the free version, to clean up 3D models if they're needed. If there's basically what's called holes in the mesh and just any errors that might make it hard for the model to 3D print. So we've got a copy of NetFab on this 3D printer computer right here that I can always run a model that you might download from Thingiverse through that program, and it generally fixes all of the issues. So, but that's just one thing to note. Once you kind of notice with some of these models, they're all in blue that don't actually have picture examples of it being printed. It's always kind of a toss-up to know if it's going to print right. But there's, like I said, software out there that can be used to fix those models so they can become 3D printable. So I'm just going to do some more exploring. I'm going to go up to Things. I'm going to go up to this All Things drop down, and I'm going to go down to, you can actually see these are all the categories that you can explore as well. I'm just going to go down to Household and see what's in there. So as you can see, these are all just like super functional things that you can 3D print. A USB cable holder, a missile switch cover, another mask, a vent cover, etc. Yeah, it's pretty much, it's kind of wild, the ingenuity and creativity that people exhibit on this website, and that the fact that they're putting these files up on Thingiverse for you to download and 3D print for free is super cool. So I would take some time exploring around on Thingiverse just to kind of see what is available, to see whatever piques your interest. Okay, so after searching around a bit on Thingiverse, I kind of decided on two things that I want to print. One thing is it's called a toothpaste tube squeezer, and I think I'm going to go with this simple one instead of this one. Some of the comments that I've read on these toothpaste squeezers that have kind of these extra little parts, people have said some of the little parts tend to break, whereas this one, this simple toothpaste squeezer, reading all of the comments, which are located there, a lot of people said this works perfectly. So I'm going to print a copy of this, and then I'm also going to print, it's called this hyperboloid pen holder, because I'd like to have an updated pen holder here at work, and these look pretty cool. And just kind of searching around, this person did a remix of this original hyperboloid pen holder. So I'm going to click on this, and this is kind of, it looks like it meets the parameters that I want. For 20 pens, the holes are 10 millimeters in diameter for each thing. So that should hold, I believe, a mix of pens and pencils, whereas the original design, I think, is just set up for pencils because of the diameter of each little hole is 8 millimeters. So I want to go with something a little bit bigger, so I'm going to choose this guy. So with each of these, all you got to do now is click download all files. You'll get this thing right there with an ad and telling you about the whole license and stuff like that. And so now what I'm going to do is click Save on File. Click on OK on that. Click over here, Download all files. You get this dialog, downloading files. And then you get the dialog to download it. So click OK. And so now those are downloaded. And I will now show you how to set these up for printing in the program called Cura. Before we go to Cura, though, I do want to mention this other website, yegi.com. This is basically, like, as they say, a search engine for 3D printable models. So they get listings from Thingiverse and other websites online. So if you can't find what you're looking for on Thingiverse, I would give Yegi a try. Some of the models that it searches through, though, go to websites where you actually have to buy the models themselves from the creator. So it kind of just depends on what you're searching for. But Yegi is also a really good resource if you are looking to try to search for stuff to 3D print. You can't find it on Thingiverse. All right, for this next section, we're going to set up the models in Cura, which is what's called a 3D printer slicing software. This is basically where you import your 3D models into the software that's going to be running your 3D printer. This is where you can set up different print parameter settings, such as scaling the print up or down, choosing what's called the layer height, and all sorts of other things like that. So, but you can actually download Cura for free. And so if you want to play around with that, you can, and go along with how I'm setting up these prints. All right, once you get into Cura, this is the interface that you will come to. Essentially, right now, we are in the profile for the Monoprice Maker Select printer. As you can see, I'm just actually right-clicking, and I can do this rotate function. But this shows you that's the build plate of the printer, and this bounding box is basically the size of the printer itself. If I go up to settings and printer, these are all different profiles for each printer we have. This is copied, actually. I've got two for the Prusa, even though we only have one Prusa printer. But yeah, so this is essentially the interface for Cura. So now to open up the 3D model that we downloaded, I will go up to this Open File dialog, and you first want to go to your Downloads folder or wherever you downloaded your model. So for the simple toothpaste squeezer, I'll just find that right there, click on Open, and then it has opened up in Cura, and this just gives you your basic idea of what it's going to look like after it is printed on your build plate. But what I'm going to do, I'm going to move this over, and I'm going to use this tool up here called Rotate to rotate it around a little bit. Because say if I wanted to print this toothpaste tube squeezer and the pen holder at the same time. I basically just need to make room on the build plate for both of those to print. So I've got that set up using the rotate function. I'm going to click on open again to open up the pen holder. Go back up to the downloads, files, and I'm going to use that guy. Click on open, and as you can see, that's what that should look like once that is fully printed. And what's cool about Cura is that it gives you a relatively somewhat accurate idea of how long that's going to take. I'd say plus or minus sometimes 5 to 10 minutes, but that's relatively an accurate description of how long it's going to take. Is 2 hours and 40 minutes for both of these. I think what I'm going to do though is I'm going to print both of these separately because I want to do them in different colors of filament, and unfortunately we can only use one color of filament per printer, so I'm actually just going to, for the monoprice printer, I'm going to print one in one color and then print the other in another color. All right, so now we have these on the build plate, but what if we wanted to change some parameters? Well, we're going to explore that now. So what's nice is that you can click on each model and that will highlight them, and then you can change the settings for each one. So if we go up here, so we can do things like move it around on the build plate using that move function. We can scale the model up or down. This can be helpful if you don't want models, if you want to make them bigger or smaller. So I can scale this down, say to 50% of the actual size, see what that looks like. You can scale it up to, say, 500%, see what that looks like. That's, of course, too big for the build plate. I'm just going to go back to 100%. I like to do uniform scaling anytime that I scale models, just so all of the parameters are basically uniformly changed. Then, of course, we have this rotate function, which is super handy. I've noticed with things like 3D scans that I've tried to 3D print for folks, the models are always sort of opened in Cura at really weird angles, like say if I just opened this pen holder and it showed up looking like this. The rotate function is really helpful for that basic thing of just changing the rotation of how you want your model to be set up. So for this, I just want it to sit flat. I'm just going to use the rotate function like that. With this model over here, I just rotated it from looking like that on the build plate to like that, just to give more room for this to be able to be set on the build plate as well. Then you've got other options too, like you can mirror prints if you want. You can do things like per model settings, so you could change model settings for each one of these separately if you wanted to. You can do things what's called custom supports, which I'll get into later once we go over the supports function. And then we have a thing called the support blocker, which I'm not going to get into today, but I will talk a little bit more about supports in the next section of the video. So over on this side of Cura, this is basically all of the different parameters that you set up before you start printing. So one really important option is what's called the layer height, and that's basically the layer of plastic that gets extruded for each layer that's getting printed. So if you have, say, a smaller layer height, say at 0.1 millimeters, your layers are going to be a lot smaller looking, which actually gives you a smoother looking surface to your 3D prints. But as you can see right here, it's slicing it right now and trying to figure out how long it's going to take. That just upped the print time to 5 hours and 17 minutes. So a lot of times I like to, kind of as a happy medium, print things at 0.2 millimeters. It's basically like a nice happy medium between things looking functional and working and not looking too coarse as far as the layer height. With the 3D printers we have, you can actually go up to a layer height of 0.3 millimeters, which will just give you more noticeable layers and make your prints look a lot coarser. And that actually does take down printing time. Right now, if we printed both of these at a layer height of 0.3 millimeters, it would only take 1 hour and 49 minutes, which sometimes I've used layer heights of 0.3 millimeters or say 0.22 millimeters if time is a factor for printing things for folks. Today I'm just going to use 0.2 millimeters, I think, for both of these, just so they look nice and not too coarse. since we have enough time to print these. All right, so the next option that we have that's kind of one of the bigger parameters that you can play around with when getting into 3D printing and setting up things to 3D print is called the infill density. Essentially, that is the denseness of the inside part of your 3D print. So this section right there, this section right there. You can choose values as low as 0%, which means the print itself will actually be hollow inside. Or you can go all the way up to 100%, which means this will just be filled with plastic all the way through. So it'll be super dense and will have some good structural integrity to it. A lot of times I like to start out at 20% infill density for certain things. If I want to go a little bit higher though, if I want some more density to the prints, I'll go up to 60, and I'll just show you right now. What's really cool is you can actually, there's a preview function under Cura. So if you click on preview right here, we're going to change our view to top-down view. Just going to scroll like that. You can actually see the infill density is this part right here, and it's actually right there on that. If we change the infill density down to like 20%, you'll actually see that the infill actually gets much wider, so that you get much more hollow, much more space. So this is all space between these little structural parts. And what's cool about this preview function is it actually can show you how it's going to be, the print's going to be built layer by layer. So that's more of the infill getting put in on this. That's the top layer for that. And then it's just going to keep building this pen holder. So a lot of times for infill density, I'll start out at 20%, or if whoever comes in wants a thing 3D printed, if they want something super dense, so it will hopefully won't break, I'll just pump up that infill density to 50% or more just for taste. You also have different options such as the infill pattern, and I'll show you what that looks like real quick. And you can play around with those settings. As you can see, Cura has explanations for all of these. So line and zigzag infill, swap direction, alternate layers, reducing material cost. Some of these other options give you more equal distribution of strength in each direction. So if we change this from grid, say, to cubic subdivision, you'll actually be able to see what that infill looks like as well, how it changes. So you can see that changed like that. We can change it also. You can see what gyroid looks like. And a lot of these settings you can just kind of experiment with. So that's what the gyroid looks like. It's pretty interesting looking. So I haven't really played around with that too much, but a lot of times I just use grid and lines. That seems to work for most prints. But you can also feel free to explore when you do get into 3D printing all these other types of infill. Cura also has a really good explanation of the infill patterns on its website, just kind of going through each setting and explaining at length more of what sort of they help out with each 3D print. So the next thing is the printing temperature and the build plate temperature. For the plastic that we use, we basically just keep it at a setting of 215 degrees Celsius and 60 degrees Celsius for the build plate. Any other sort of plastics you're going to use will also change those values. Like there's a plastic called PETG that's a little bit stronger in strength. They're recommended as a alternate to using ABS plastic, but PETG, usually you have to print that at 240 degrees Celsius with a build plate temperature of like 80 to 90 Celsius. But primarily we have PLA plastic here in the Makerspace, so I just keep these values at this and then change them to taste for, say, the 1 or 2 rolls of PETG that we have in here that I sometimes print with. Then in terms of print speed, all 4 of our printers I have actually running at 90 millimeters per second for the print speed, and then travel speed at 120 millimeters per second. That seems to be kind of the fastest they can go. They really can't go faster than that, or else if you try to push them harder than that, a lot of weird artifacts end up showing up in your prints. I've also noticed too, though, you can decrease your print speed if you're having issues with certain types of models that you print. I've noticed like certain models, such as like Dungeons and Dragons figurines, which are actually kind of difficult to print anyways because of the detail. If you print them a little slower, like say at 40 millimeters per second, the details tend to be kept at least a little bit better rather than printing at a fast speed. But for the most part, for most things that I print at in here, we just start with the print speed of 90 millimeters per second, and then we can always decrease it to taste. All right, so another setting in Cura that you'll come across that is actually super important for a lot of models that might have any weird angles as they're being printed, it's called support. Thankfully, actually, none of these two models, they do not need support because they are laying just completely flat on the build plate. But if we did need support, I'll show you kind of why it would be needed. So let's say if for some reason we imported this model into Cura, we wanted to print it, say, I don't know, on its side like that. Essentially, it's going to need what's called support, which when I click on this generate support function, I'll show you. Click that, and since we're still in the preview mode, it'll actually show us what it should look like. So support is basically just some extra plastic built beneath the model itself to essentially support it as it's being built. So this is going to generate a ton of support right here, which would just be a lot of wasted plastic. So pretty much you really only need to generate support for particular models where you have these angles that are essentially, 45 degrees or lower. Anything like that is going to need support, because if you do try to print this model like this without any kind of support, at a certain point, likely down here, if it doesn't have support, the extruder nozzle itself is just going to start spitting out the plastic, almost kind of like spaghetti string, and you'll just be left with a mass of plastic, and you'll have a failed print. So pretty much anytime you have a model that you have to print at kind of weird angles, you'll need support. So if we wanted to print this model like this, we would actually need to print support down here, and probably likely we would need to print support going up through here. So your options that you have for printing support, you can have it either touching the build plate, or you can actually have it set everywhere. I mean, it's hard to know. You could always experiment and see if you wanted to print this print like this, upwards like that, and see if this could print without support. You could try it, but the likelihood is that it might fail, which would be unfortunate to have to use up so much plastic to print this. One thing you can do, though, is you can play around with the support density. You can increase that or decrease that, and that's just going to increase the amount of support that's created on your model. Thankfully, with this model in particular, as well as this one, we can actually just print these flat like this, and so they don't need support. But another example is if, for some reason, maybe we wanted to print this model with the pen holes flipped around, like this. So it's printing flat with the pen holes face down like that. We're also going to need support as well on each little hole as it's being built in order to support these top parts of the structure. So as you can see, you can actually do a quick little walkthrough of what it would look like. So this is the third layer, and as we go up on the built layers, the support is getting built right there. As you can see, it's that turquoise stuff. So, and what's nice about support, though, is essentially you can rip it out easily from your model when it's built in. You just need some needle nose pliers, and you can just take each little part of support and rip it out. So it's pretty easy to remove for the most part, especially if you keep your support density at a low percentage, such as 5 or 10 or 15%, it makes it much easier to get rid of that and remove it from the actual print itself. But as an example too of when you might need support, say if you wanted to print this at this kind of weird angle like this, you would need support, and it will show you what that's going to look like in just a sec once this preview gets done. So that would be support that would be built into that model. As you can see, it actually ups the time because it's just extra plastic. It's little kind of scaffolding layers of plastic that are built beneath the model itself, just to give it that support that it needs in order to have it be built at those angles. I've noticed a lot of times with certain things like 3D scans, you do generally, unless you have a part of the scan that's super flat that can just sit flat on the build plate, you have to use the rotation tool as well as generating support in order to support some of the functions of trying to print that 3D scan. But of course, every 3D scan is different, much like every 3D model that you find online is different. So, but that's just goes over the support settings, which is, as you can see, sometimes needed and other times is not needed, just depending on what kind of model that you're planning to print. So the last setting we'll go over today is called build plate adhesion, and essentially you'd use build plate adhesion if, say, the glue stick that I used, that I smeared onto the build plate, just wasn't helping the plastic adhere nice and flat to the build plate. You want to use build plate adhesion just as that kind of extra step to make sure that your model can be built nice and flat on your build plate. And I'll show you what types of adhesion they have. I'll just go up to preview up here. So the first one you've got is skirt. Essentially, that's basically just kind of priming your nozzle before it starts printing, just to make sure your nozzle is nice and clear, a filament. So it just basically makes this nice kind of line around your models that are going to get printed. The next option is called brim. And that's basically like a thin layer of plastic that is going to be printed just on like the outside of each model, as you can see like that. And that basically just gives a little extra adhesion to your model if you're having problems with the first couple of layers of the plastic sticking to your build plate, which can be one of those issues you'll come across in 3D printing. So using this kind of build plate adhesion can help with that. And then if you're really having problems with getting the plastic to stick nice and flat and having the model basically build nice and flat to your build plate area, you can use what's called a raft. So that's actually going to be I'll show you, kind of move this, a larger, thicker layer of plastic that gets built beneath your model like that you will just simply rip off the bottom of the model after it's printed. Let's see if it will build it on this guy. Oh. I think I have to move this out to the middle in order for the raft to get built on this, because it's outside the parameters of the build plate. All right, so yeah, as you can see now with this, so the raft itself is this flat plastic mass being built beneath the model. So you don't have to use a raft too often unless you're having really horrible build plate adhesion. But there are those times when, say, if I've printed things at, much like when I need to use support, if I was to print this at an odd angle like this, I'd want to use support, and I'd probably want to use a raft as well, just to make sure that the plastic in each layer really adheres nice and flat to the build plate surface. But I don't need to do that with this particular model, but that's just another option too, in terms of trying to get your prints to stick nice and flat to the build plate. Before we actually start printing, I'm just going to go over one other extra setting that Cura offers, which is pretty cool. They're called extensions. Essentially, they're plugins for increased functionality for your 3D printer and your prints. So one thing that's cool is it's got it's called a Barbarian plugin, which means you can convert models that might have been modeled in inches to metric, or you can use this mesh tools, option to actually check your models and fix simple holes, things that basically will make it so your model is not printable. There's also an auto orientation feature, so if you once you import your model into Cura, if the orientation seems a little weird or you kind of want to try to figure out the best way to print it, you can use these two settings to see how it might print either in a fast way or an optimal way. Then in order to get more extensions to increase functionality further, you just want to go up here to Marketplace, and you will get this dialog right here that you can kind of explore, like community plugins. Say if you use the CAD software Blender, this allows opening of Blender files directly into Cura, which is handy if you use Blender. So there's just all these extra plugins that you can play around with. For most of these printers, I use what's called Octoprint. So that's basically just a 3D printer networking software that runs on a Raspberry Pi. And this essentially enables Cura to connect with the Raspberry Pi itself and the instance of Octoprint that's installed on that in order for us to be able to use both of those things together for printing. So, but yeah, feel free to explore this marketplace. It's pretty cool. There's also different plugins you can get for different kinds of materials that you might be printing with, etc. One other thing to note, as your print is printing, you'll see over here in this monitor section right there, the values up here will actually show you the extruder temperature, your build plate temperature. It'll also show you an estimated print time, which I've noticed can be off a little bit. Usually it's generally in the higher range. So I generally, in terms of kind of trying to figure out how long a 3D print is going to be, I will go with that time right there. But also under the monitor section, if you need to cancel or pause your print, you can use these buttons right here. All right, so I am all ready to go, and I'm ready to get this pen holder printed up. So next thing I'm going to do is print with Octoprint. I have Cura connected with the Raspberry Pi single board computer that's got this 3D printing networking software called Octoprint on it. So I will just click print with Octoprint, and what it's going to do, it's sending the information to Octoprint. And as you can see up here under the monitor section, extruder is going to be heating up. The build plate will also be heating up. And I will now switch over to the camera, and you can watch a time-lapse video of the print itself. This section, I actually ended up just taking some of the footage and then speeding it up a little bit instead of doing a time-lapse. But as you can see, it's just building the pen holder layer by layer. And yeah, the whole process is basically, it's just each layer of plastic gets extruded, and then it just keeps building and building each layer until it reaches the final layer and you're done with your print. On this section, this is where the toothpaste tube squeezer is being printed out. And it actually took a lot less time than the other print. I believe the total time, I think, was 35 or 40 minutes. But as you can see, it first just starts out with those initial layers, and then it just keeps building up and up and up until you have your final product. And I will show you at the ending videos how they turned out. So stay tuned. Hey everyone, I just wanted to show you how the 3D prints turned out. So this is the pen holder. It turned out really well, I think. I love the color of the filament that I used. And as you can see, it's just like a super simple but super functional thing that does have just a really cool look to it. But the print itself, I didn't come across any snags. It took about 2.5 hours, I think, to print all together. So I want to give a shout out to the Thingiverse user MHSON for uploading that and letting us print it out. And then for the second print, this is the toothpaste tube squeezer. As you can see, if you print this out and use it, you are not going to be wasting any toothpaste. So I took this home last night and tried it out, and it is a super cool functional print that I'm going to use now forever. So I'm super happy with how these turned out. So hopefully you enjoyed watching the process of printing and how we got everything set up. So with that, I just want to thank you for watching this tutorial. I hope you learned a lot about our 3D printers, where you can find things online to download and 3D print, as well as the software that runs the printers. Please keep an eye out on our website at MissoulaPublicLibrary.org for updates on when we're going to be open to the public into our new building. And I'm also going to include at the bottom of this video my email address, so if you have any questions, feel free to email me. That's the best contact for me right now as we're transitioning to get into the new building. So feel free to reach out if you have any questions or if you want anything 3D printed, because I can do that as of now. So thanks again for watching. Have a great summer and take care.